If you found crude oil near your home, would you pour it into your car and drive?
Don't. Crude is thick and dirty. It clogs injectors, smokes badly, and can kill the engine in minutes.
Crude oil is a messy soup. Light gases, mid-liquids, heavy tar, and impurities like salts and sulfur mixed in.
Refining does three things. First, separate by boiling point, then upgrade molecules, then blend products to meet engine standards. Step 1. Desalting. We mix in water. Salts and dirt move into the brine, then drain away. Next, we heat it hot enough to vaporize parts of it, before shooting the mixture into a tall column. In the column, heat rises and cools. Light vapors condense high up. Heavy liquids condense low and fall back.
Top to bottom. Gas, gasoline, jet fuel, diesel. Then, perfect for energy.
Gasoline moves cars, kerosene powers jets, diesel hauls freight, and the heaviest leftovers become the asphalt under your feet. And this is only the start. Next, cracking heavy oil into more gasoline and cleaning sulfur so fuels burn safer.
We add a vacuum so heavy oil can boil without burning. Then we pull out even heavier useful fractions.
The bottom leftovers aren't waste. Some become asphalt for roads, and some become base oils for lubricants. Cracking is the magic. Heat plus catalyst breaks big molecules into smaller ones, making more gasoline-range fuel. Reforming upgrades gasoline. It reshapes molecules so fuel resists knocking and engines run smoother. Before fuels ship, we hydrotreat them, adding hydrogen to strip sulfur, so exhaust is cleaner and safer.
That captured sulfur isn't trashed. Refineries recover it into yellow sulfur used for fertilizers and industry.
Last step, blending. We mix different streams so the final fuel meets performance targets every time. Then it travels. Pipelines to terminals, trucks to stations, and special systems that fuel airplanes safely on the runway.
That's why you can't use crude directly. Refining needs heat, pressure, catalysts, and strict safe control to make stable fuels.
And one more twist. Some fractions become chemicals, like naphtha turning into plastics. Next, I'll show that path.
In a steam cracker, naphtha hits blazing coils for milliseconds. Then it splits into basic building blocks.
After cracking, we separate the mix, pulling out ethylene, propylene, and other streams, each for different materials.
Ethylene links into long chains, polyethylene, then gets chopped into pellets, the raw Lego bricks of plastics.
Those pellets become bottles, food containers, wire insulation, toys, light, tough, and cheap to shape at scale. Other streams become chemicals for paints and solvents, and even fibers. Think nylon and polyester in everyday clothing. Diesel is the workhorse, powering trucks, buses, construction machines, and generators, where torque and efficiency matter. Jet fuel must stay fluid in extreme cold, so it's refined and tested to avoid waxing at altitude.
Safety is built in. Pressure relief sends excess gas to the flare, burning it in a controlled way.
Refineries also treat water and gases, separators, scrubbers, and monitoring, so the plant runs cleaner and safer.
So no, crude won't run your car. Refining sorts, upgrades, and cleans it into fuels and materials we use daily. If you found crude oil, would you pour it in your car? Don't. It's thick, dirty, and it will ruin systems fast. Crude clogs filters, stresses pumps, and won't atomize cleanly, so combustion turns smoky, weak, and damaging. First, crude gets washed and desalted. Water pulls out salts and grit that would corrode equipment downstream.
In the main tower, heat sorts by boiling point. Light parts rise, heavier parts stay lower, and we draw each cut off.
And vacuum distillation pulls more useful oil without overheating. What's left becomes very heavy residue. Hydrotreaters add hydrogen and catalyst to strip sulfur. Cleaner fuel, less smell, and far fewer harmful exhaust compounds. Reforming rearranges molecules into better gasoline blend parts, so engines resist knocking and run smoother.
Finally, refineries blend streams like a recipe. They'll test and tweak with additives for performance, stability, and safety.
Crude also becomes LPG for cooking, asphalt for roads, and lubricants that protect engines every single day.
That's how crude becomes fuel and materials. If this helped, subscribe. Next, we'll break down another mystery technology.
Distillation only sorts. The real magic is cracking, breaking heavy oil into lighter, useful fuels. In FCC, hot catalyst meets heavy oil and cracks it in seconds, turning thick leftovers into gasoline-range vapors.
Hydrocracking adds hydrogen under pressure, making cleaner diesel and jet fuel with fewer impurities and smoother burning.
Some naphtha becomes petrochemicals, ethylene and propylene, then plastic pellets for packaging, bottles, and endless everyday items.
That kerosene cut becomes jet fuel, treated for stability, so it burns reliably even in freezing, high-altitude air. Gasoline powers most cars, diesel moves trucks, and heavy fuel oils push cargo ships across the ocean.
The thick residue becomes bitumen, roads, and waterproof roofs, sticky when hot, rock hard when it cools.
Every product must meet strict specs: octane, cetin, sulfur, flashpoint, so engines run safely and predictably.
So when you buy fuel, it's not oil. It's an engineered blend, cleaned, upgraded, and tuned for your engine.
Which surprised you most? Jet fuel, plastics, or asphalt? Comment it and subscribe for the next How It Works breakdown.
Before blending, refineries hydrotreat fuels. Hydrogen and catalysts strip sulfur and gunky compounds for cleaner burning. That removed sulfur isn't wasted. Many refineries recover it as bright yellow sulfur for fertilizers and industry. To stop engine knocking, refineries reform molecules, rearranging them to raise octane without changing the fuel into crude again.
Final fuels are blended like a recipe, different streams plus tiny additives for stability, cold starts, and cleaner injectors. After blending, fuels sit in giant tanks. Floating roofs and vapor systems help reduce evaporation and losses. Pipelines move fuels in batches, gasoline, then diesel, kept separate by tight control and a clean interface zone.
They even send pipeline pigs through, tools that clean buildup and inspect the line while products keep moving.
Raw crude would clog filters, foul injectors, and burn dirty. Your engine needs refined, stable fuel, not sludge.
Fuel is safe when controlled. Fire needs fuel, oxygen, and heat. Remove one, and the danger collapses.
That's how crude becomes fuels and materials. Want the next deep dive?
Quick recap. Crude oil is messy soup. Refineries separate it, clean it, and tune it into usable products, fast and safely.
If you pour crude into an engine, it's like feeding mud to a precision machine. Refining turns that mud into controlled liquids.
Think of the tower like a temperature ladder. Hot at the bottom, cooler at the top. Each product chooses its level.
Top gives light gases, then gasoline-range liquids, then diesel and jet fuel, and the bottom becomes heavy oils and asphalt.
If you found crude nearby, pouring it into your car won't work. It's the wrong volatility, full of impurities, and it burns unevenly.
Gasoline must vaporize easily for spark engines. Refining controls volatility and octane so combustion happens smoothly, not violently.
Jet fuel is tuned for turbines. Steady burning, high energy density, and reliable flow even in freezing, high-altitude air.
Diesel is heavier and less volatile. It ignites from compression heat, perfect for trucks, ships, and machines that need torque. The heaviest leftovers become asphalt and heavy oils. That's why the bottom of the tower literally turns into roads. Not all of the barrel becomes fuel. Some fractions become petrochemical feedstocks, starting points for plastics, fibers, and countless materials.
Refineries run at high heat and pressure. Safety systems keep reactions controlled, because this is chemistry, not a kitchen.
Step 1 is distillation. Heat crude, then collect vapors at different heights because each fraction boils at different temperatures.
For deeper processing, refineries wash out salts, water, and grit. Less salt means less corrosion and cleaner downstream equipment.
Next, treating removes sulfur compounds. Cleaner fuel means less smelly exhaust and fewer pollutants when it burns.
Separation isn't enough. Refineries also convert, cracking heavy molecules into lighter ones to make more gasoline and useful middle fuels.
This is gasoline's job, quick vaporization for spark engines. That's why refineries tune it to tight specs, not guesswork.
Jet fuel has to stay predictable at altitude. Refining controls freezing behavior and burn stability so turbines stay smooth and safe.
Heavier middle fractions power ships and heavy equipment. Compression ignition loves dense fuel and steady torque. Some fractions become lubricants. That thin oil film prevents metal from grinding, cutting friction, heat, and wear in engines. So, crude gets separated, cleaned, and converted into gasoline, jet fuel, diesel, asphalt. At the bottom is asphalt, too heavy to burn cleanly, but perfect for tough, waterproof roads and roofing.
Some light fractions become petrochemicals, feedstock for plastics, fibers, and solvents. Fuel is not the only product here.
Think of it like sorting a mixed box. Some pieces become car fuel, some plane fuel, some ship fuel, some roads, and some plastics.
After refining, products get blended. Tiny additives and careful mixing make fuels meet performance and safety requirements.
Crude is a messy mix. Gasoline is a tuned slice with controlled volatility, so it vaporizes and ignites the way engines expect.
Gasoline for spark cars, diesel for heavy torque machines, jet fuel for turbines, and the heaviest stuff for roads and industry.
Picture a temperature ladder. Hot at the bottom, cool at the top. Vapors rise, then condense where they belong. That's distillation.
If you remember one thing, refineries separate, then treat, then convert. That's how crude becomes reliable products.
Now you know why crude can't go straight into your car. If this helped, like and subscribe.